Good evening. In this video, we are going to discuss proposition 8 from book 2. So this proposition states that if we are given a finite straight line, for example, AB, and a random point on AB that cut AB into two segments, for example, A and B, C is a random point, and then the proposition says that 4 times of the rectangle contained by the whole, which will be 4 times the rectangle contained by the whole will be A plus B times B, this is the whole, this is segment, plus the square on the remaining segments. AA is the remaining segment, so this is the square on it, will be equal to the square on the whole together with the aforesaid segment. Okay, so this is the whole and B is the aforesaid segment, right? So we will have A plus B, this is the whole, and this is the aforesaid segment, correct? Equals to the squared on it, square. Okay, so let's try to prove this equality. So I would like to say the construction steps in this proposition is really time consuming, so we'll just skip the construction steps, and I would like to give it a brief description. Okay, so at first we will apply postulate 2 to extend AB to somewhere, and then apply proposition 3 from book 1 to cut off BD that is equal to BC. So this is also B, okay, from the straight line. And then we can construct this figure using proposition 46, construct a square, proposition 31 to construct a parallel line, as well as postulate 1 to connecting to different points. The detailed steps are described in, I believe, in proposition 4 from 7, 4 propositions. So if you can remember, just recall them, okay? Let's just assume we have completed the construction and we have this figure, okay? So let us give it a proof. First of all, please recall proposition 34 from book 1. The opposite sides of a parallelogram are equal. So we have CB is equal to MO, opposite sides, correct? And BD equals to OK, correct? And we've already known that CB is equal to BD, correct? So if we combine them together, we can conclude that, apply combination 1, okay? We can conclude that MO is equal to OK, correct? And if we apply, let's say, proposition 36 from book 1, we know that if two parallelograms have the same or have the equal base and they are in the same parallels, then they are equal. So please have a look at it. Oh, let's give them some new names. Let's call this R1, R2, R3, and R4, and this is S1, S2, S3, and S4. Okay, so we know that S1 must be equal to S2 because they have the same base and they are in the same parallels and they are parallelograms. Okay, and similarly we can prove that S3 is equal to S4, same proof. And please pay attention to this sub figure CNLD, or let's say it's ND. In previously proved propositions, we know this is a parallelogram. So ND is a parallelogram, and S1 and S4 are two complements about the parallelogram. So if we use proposition 43, we know that the two complements about a diameter in the parallelogram are equal. So we know that S1 will be equal to S4, correct? And if we combine them together and apply combination 1, we know that these four are equal. Correct? And we have proved that OD is a square and NO is another square. So S2, S3 are two squares. If you can't remember, just review proposition 4 from book 2. We have proved it. So square must be equilateral because of definition 22. This is definition of square. So we know that in this square, we know that BD equals to BO, correct? And we also know that BD equals BC, plus we know that BO equals to CM. BO equals to CM because of proposition 34. They are BO and CM are two opposite sides of a parallelogram. So if we combine them together, we can conclude that, let me check, conclude that CM is equal to CB, correct? So this is also B equal. And S3 is another square. It is on the diameter of this whole parallelogram, or let's say this whole square. We have proved it, so let us just use the conclusion. If this is a square, it must be equilateral, so these sides must be equal to this. So we know that MO is equal to MN, and MO is also equal to CB because they are two opposite sides of a parallelogram MB, correct? MO equals to CB, and combine them together, we know that MN is equal to CB, correct? So they are equal. So this is B, this is also B, correct? And then please pay attention to R1 and R2. They have the equal base. CM is equal to B and MN is also equal to B. So they have the same base and they are in the same parallels, CN and AH. So if we apply proposition 36 again, we know that R1 is equal to R2. And with the same proof, we can conclude that R3 is equal to R4. And pay attention to this parallelogram, this subfigure, parallelogram EO. So in this parallelogram, R2 and R3 are two complements about the diameter here, correct? And if we apply proposition 43, we know that two complements are equal, so R2 will be equal to R3, correct? And if we combine them together and apply common notion 1, we know that these four are also equal. So R1 equals to R2 equals to R3 equals R4, correct? And then please have a look at this nomen. Just recall the definition of a nomen, these three parts of a parallelogram. So let's call it nomen HDI, okay? So nomen HDI equals, have a look at this figure, equals to R1, but let's give it summarize. So it is equals to the 4R plus those 4S, correct? And this describes a nomen, and if we apply these two equalities to this nomen, to this equality, we know that the nomen HDI also equals 4 times of let's assume R1 plus S1, okay? So this is nomen. And have a look at this whole square. We know that the square ED equals to the nomen plus the fourth part, this is also square, plus EN, okay? So it equals we also know that square ED equals to nomen HDI plus square EN, correct? And if we combine them together, we can conclude that the square ED equals the square EN plus 4 times of R1 plus S1. Okay, so let's have the algebraic expression of this equality. So ED the square will be equal to A plus B square. Okay, oh, I'm sorry, A plus 2B, because this is A, this is B, so it's A plus 2B square. It is equal to the square EN. This is A. We have proved it in proposition 4. Let us just use the conclusion. This is also A. This is a square. So it is A squared plus 4 times of Rn plus S1. R1 plus S1. R1 plus S1. It is this rectangle. And if we recall the definition of a square in 22, S2 is a square, so it's equilateral. So this side is also equal to B. So if we describe the rectangle R1 plus S1, it will be A plus B one side by another side B, and A plus B is a whole, B is the segment. And if we compare this conclusion with our proposition, we know that they are equal, so they are equivalent. We have proved proposition 8. In this next video, we are going to discuss proposition 9 from book 2. Thanks for watching. Have a good day.